Welcome to Lecture 5 on elasticity. We're going to look at how to calculate an elasticity of demand or supply. We're going to look at types of elasticity, how that can affect changes in both quantity and pricing of both supply and demand, and then how we can measure it in other areas. So if we were to look at a demand line here, and I know it's a demand line because it's going down, remember, and I was trying to calculate the elasticity. I have to understand the percentage changes, and so there's a couple different movements between G and H. You'll see that highlighted here, and between A and B, and I'm just going to assume that A comes before B, G comes before H. That's why I've calculated it the way that I have. And the first thing I have to do is understand the difference. So the difference in the quantity, so we went from 1800 to 1600, that's a difference of 200. But we started with 1800, so that's the original amount. Take out your calculators, 200 divided by 1800, is going to give you approximately 11.11% change. And then from A to B, we went from 3,000 to 2,800, also a change of 200, but the original amount was 3,000. So 200 divided by 3,000 will give you 6.67% approximately. We can do the same thing with price. If we go up to G and H, it went from 120 to 130, a change of 10, but originally it was at 120, that price point over here. And then from A to B, it went from 60 to 7, also a change of 10, but it started at 60. And when you do your calculator, you'll get different percentages, 8.3 and 16.67. And now I can compare the change in quantity with the change in price from G to H. That's listed here. I can do the percent change in quantity and the percent change in price for A to B. That's listed here. And so you could practice those calculations and make sure I actually did them correctly myself. The price elasticity then is calculated by the percentage change in quantity divided by the percentage change in price, which is what we just showed. And this is another example looking at it where we went from 10 to 13, a difference of 3, but starting at 10, that's the change in quantity. We went from 650 to 750, or to 700, 650 to 700, a change of 50, starting at point A at 650 as the price right over here, this bottom one. And that shows us a 7.7%. And then we take the change in the percentage of quantity divided by the change in the percentage of price, and we get an elasticity number, in this case 3.9. What you should know is that when elasticity is greater than 1, we call that elastic. And you'll see a flat tire on the picture screen, and that's because you'll see graphically elastic lines are more flat, and so that flat tire is to kind of remind us of that. Inelastic means that price elasticity is less than 1, and you will see the picture of the car going up the steep incline. The more vertical or the more steep a curve is, the more inelastic that curve is. And then on some rare occasion, you might have something that the elasticity equals exactly 1, so that's given a special name, unit elastic. So most things are elastic or inelastic, greater than 1, elastic, less than 1, inelastic. If it happens to equal exactly 1, we call it unit elastic. So I like to think of my son, who always would run around planking different places we would go when he was younger. But you can see that whether it's a demand curve or a supply curve, if it's flat like this, we call it elastic. I also think of it as going to sleep, the flat tire, the planking, or laying in bed. elastic. Inelastic, upright, whether it's a demand curve or a supply curve, perfectly elastic, straight up and down. Reminds me of going to the Buckingham Palace, seeing the changing of the guards and the guards standing at apt attention. But that idea of being very rigid, or the steep inclining car, a picture of being up and down, I kind of think of myself in soldier format. I'm inelastic. And a demand curve, it turns out, or a supply curve, they're called curves, but lots of times we draw them as lines. One of the reasons we call them curves is if you wanted a very consistent elasticity, the curve, it would need to be bent. It couldn't be a straight line. And so this curve is an example of the same elasticity along the entire line, an elasticity of 1, unit elasticity, that the percentage change in quantity and the percentage change in price are exactly equal no matter what point you move to, from A to B or B to C or C to D along that demand curve. And so you have to make the line curved in order to have a consistent elasticity all along that curve. Now we're back to our straight lines though, and again, just a reminder that the more vertical, so in this case, this demand line is fairly vertical, the more inelastic or rigid, or like the soldier it is, the more flat, like the tire or planking it is, the more we call it elastic. And so you've got an inelastic demand and an elastic demand shown here, and that just could be based on if it's a life-saving drug, then I'm willing to pay a lot more and I will still probably buy the drug. Some people may not, but many of us will, because it's important enough to us that we'll spend the extra to stay alive. If it's something that's much less we're concerned about having to have, if my coffee goes up too much, then I might just switch to a different brand or a different cafe to get my coffee at. There are examples listed here showing inelastic and elastic demand. And so you could pause the video, you could read the material at the bottom. It just kind of takes you through a scenario and explains what's happening in the graphs. And it's really helpful for you to do that. So it's great that you can pause these videos when it makes sense to you. Maybe you're just hungry and need a little break. Income elasticity is how responsive change in quantity demanded is to changes in income. And so the example that jumps to my mind, the formula is very similar to what we've done before. We practiced calculating it a couple times. You've got that percentage change in quantity divided by that percentage change in price. If it's greater than 0, we call it a normal good. If it is less than 0, we call it an inferior good. And I will tell you that when the price of gasoline was up above $4 a gallon, and I was testing to see, would I go over $100 when I filled up my tank this time, it was beginning to impact how I thought about what cars I would own and how I drove those cars. So I was driving a big Tahoe at the time, and I would find myself coasting a lot of times, so I didn't have to use my brakes as much, and was getting better gas mileage, because it gets terrible gas mileage. But it literally changed. That change in price of gasoline changed the kinds of cars that we as Americans bought. So if you really wanted to reduce carbon emissions in the U.S., you would force us as a population to buy much less trucks and large SUVs if you simply raised significantly the price of gasoline. And what happened was we saw a spike in the purchase of automobiles, actual cars, and a much larger decrease in then the purchase of trucks and large SUVs. So cross-price elasticity starts to look at how the price of two things relate to each other. If they move in concert with each other, if they're correlated, if they move in the same direction. If they're substitutes of one another, then you can look at a positive elasticity. If they're complements to each other, a negative, you get a negative cross-price elasticity. But we're trying to understand how the price of one good might change to the price of another good. So the exercise for today, you actually have a choice. And you can respond to the first bullet or the second. You do not need to respond to both. If you do, that's perfectly fine. But you are only required to respond to one. One looks at artists. We say when an artist dies, that's when their work becomes more valuable. And I want you to, using what you have learned through your reading, through this short lecture, think about what is true thinking of elasticity and why that might be that artists' work is more valuable after they die than when they're alive. And then something that happened fairly recently, although during the pandemic, I'm not sure what they've done. Disney World instituted strategic pricing, charging different prices based on demand, the number of people who wanted to come, and that's related to the time of year that it is. And it's caused overall attendance at their parks to actually decrease, but it actually increased the overall revenue of the parks. So they were making more money. If you came into the park, you could actually wait in shorter lines, get on more rides, but you were paying more at peak times to get access to the park. So how does the concept of elasticity then explain why Disney implemented this pricing and what the results were? Again, please respond to one of those two questions, and I'll look forward to talking to you next time.